All right, so our learning goals today are, first one is I can construct an indirect proof. We've already talked about two-column proofs, paragraph proofs, coordinate proofs. This is a different type of proof called an indirect proof. The second one is I can know and use inequalities in one triangle. Hey, when we write an indirect proof, these are the steps that we follow. Step number one is you always identify the statement you want to prove, and then you assume temporarily that this statement is false by assuming the opposite is true. Step two, you reason logically until you reach a contradiction with your assumption. And then point three, that means that the original statement has to be true because your assumption is false. These are kind of confusing, but they're also a way around. Sometimes it's really, really hard to prove something directly. And so we can approach it using these type of proofs. Here's an example. Write an indirect proof that in a given triangle there can be at least one right angle. So what we always start with is what you're trying to prove right here. We're trying to prove ABC can have at most one right angle. So what we're going to start out by saying is assume triangle ABC can have more than one right angle. Okay, so ABC can have at most one right angle. We're going to say assume ABC can have more than one right angle. Now what I have to do is come up with a contradiction. Like why can my assumption not be true? If I can prove that this is false, that means that what we're trying to prove up here has to be true. So let's see, let's say if I assume it can have more than one right angle, let's say that angle A is equal to 90 degrees and angle B is equal to 90 degrees. Well, 90 plus 90 equals 180 degrees. And we have a contradiction right there because I still have one more angle, right? Angle C, if that's true, the angle C would have to equal 0 degrees, and that's not possible. Right? Because all the angles have to add up to be 180, and if C is 0, then they're not going to add up. So therefore, my assumption up here is false. My assumption is false, and the original has to be true. So I'm going to come down here and say, therefore, and those three dots just mean therefore in math. Therefore, triangle ABC can have at most one right angle. Okay, so we start out, assume whatever you're trying to prove, assume the opposite is true, and then show some kind of contradictions. Show why your assumption has to be false. And if this is false, right, if this assumption right here is false, if that's false, that means that this has to be true. So that's why they call it an indirect proof, is you're not proving it directly, you're proving that the opposite is false so that it has to be true. You're kind of forcing it to be true. Let's look at one more. Pause this for just a second, and I want you to write just the first step. Write the temporary assumption. So what is the opposite of what they are saying here? And then we'll write that down. We'll check that, and then we'll go through the entire proof. So it says, write an indirect proof that a scaling triangle cannot have two congruent angles. So my assumption is, assume that a scaling triangle has two congruent angles. Okay, if you remember a scaling triangle, the definition is that all three sides are different lengths. Okay, so if we assume that a scaling triangle has two congruent angles, let's say, come down here, that means, it looks like this. Well, hopefully remember, if you have two congruent angles, that means that it's isosceles, that it has two congruent sides. So those two sides have to be congruent. If those two sides are congruent, that means it's Isosceles. I'm not going to write out the whole thing. Okay, it's an isosceles triangle. If it's isosceles, it has two congruent sides. Well, that's a contradiction because a scalene triangle can't have any congruent sides. Therefore, our assumption is false, right? This is false right here. So the opposite has to be true, which it means that a scalene triangle cannot have more than two congruent angles. These take a little getting used to, but hopefully the idea is there. You always assume the opposite, and then you show why your assumption can't be true, and that proves that it has to be true. Okay, that's the first part of the assignment there, is just working a little bit with this new type of proofs, these indirect proofs. The second half is dealing with something different. To introduce it, I want you to pause this. Well, let's read through it first, and then we'll pause it, and I want you to see if you can figure it out. So it says, for a neighborhood improvement project, you volunteer to help build a new sandbox at the town playground. You have two boards that will make up two sides of a triangular sandbox. Whoever heard of a triangular sandbox, right? One is 5 feet long and the other is 8 feet long, right? So here's my boards right here. There's my 5-footer, there's my 8-footer. Boards come in the length shown. Which boards can you use for the third side? So the question is, could I use a 15-foot, 12-foot, 8-foot, 5-foot, 2 feet? There is more than one correct answer here. So I want you to pause it and think about which one of those would work. Then you can start it again and we'll talk about it together. Okay, what would happen if I took that 15-foot piece, right, 15 feet, and then if I took the other two sides, right, if I took the 8, so I do the 8-foot piece and the 5-foot piece, okay, they wouldn't meet up, like they're not long enough. In fact, even if I laid them flat, right, even if I laid it flat alongside here, 8 feet and 5 feet, there's going to be a gap there. Like there's no way that they could form a triangle. The 12 feet would work, and the reason why is because, think about if I lay them flat again. If I had 12, and then I laid down the 8, and I laid down the 5, they would overlap, which means I could actually put them up like this. It wouldn't be a big triangle, but I could make a triangle that would fit with those. So long story short, those two sides have to be longer than your third side. So the 8-foot one would work also, right? 8 plus 5 is 13. It's longer than my third side. If I get down to the 5-foot one, now it's kind of flipping it around. Now my longest side is 8, and my two shorter sides are 5 and 5. But if I add my two shorter sides together, 5 plus 5 is 10. That's longer than my longest side, so we're okay. If I try this last one too, now my sides would be 2, sorry about my board there, 2, 5, and 8. Well, if I add up the two shorter sides, 2 and 5, it doesn't add up to be longer than 8, right? This is 8, the 2, and the 5. They'd be too short. They would never meet. So the answer is, that one doesn't work, that one doesn't work. Any one of the middle three would work. So that's what we're doing, is we're looking within a triangle, we're looking at it and we're comparing the sides and also the angles. That's what they call this inequalities in one triangle, because we're just looking at a single triangle. We're going to skip past that. So here's your first couple of theorems, and I think hopefully these theorems make sense. It says, if one side of a triangle is longer than the other side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So if I look within a triangle, what it's saying is this: if this side AB, right, if AB is bigger than BC, right, AB is bigger than BC, now we look at the opposite sides. So what I mean by that, let me actually use different colors here. AB goes with that angle, and BC goes with that angle. So you always look at the angle opposite the side. So in this case, if this side is bigger than that, than the one I outlined in blue there, that means angle C has to be bigger than angle A. So by comparing the sides, you can compare the angles. The same is also true with their angles. It's just going the opposite way, right? If one triangle of a triangle is larger, if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. The key thing is to look at the opposite side. So if this is angle A right here, this is angle A right here, it's 50 degrees. That goes with this side over here. Okay, this one, angle C, excuse me, is right there. It's 30 degrees. It goes with that side over there. So which one's a bigger angle? The 50 degrees is bigger. So that means that side BC, maybe actually I'll stick with my colors. That means that side BC, which is outlined in red there, has to be bigger than the side opposite the 30-degree angle, which is AB. Okay. So opposite sides are opposite the bigger angles, shorter sides are opposite the shorter angles, and it goes both directions. So this says you're constructing a stage prop that shows a large triangular mountain. The bottom edge of the mountain is 32 feet long. So let's label that. The bottom edge of the mountain is 32 feet long. The left slope is about 24 feet long. This one's over 24. And the right slope is about 26 feet long. List the angles of JKL in order from smallest to largest. So we're going from smallest to largest. Start with the smallest side. If this is the smallest side, that means angle L has to, the opposite angle has to be the smallest angle. So L would be the smallest. The next smallest side is 26, so this would have to be the next angle. And the largest angle is 32. That would have to, so the largest side is 32, so K would have to be the largest angle. Okay, so pretty easy. Just start with the shortest side, it's opposite the smallest angle. Longest side, it's opposite the largest angle. You guys do this problem real quick, and then we'll talk about it together. So if we're listing these from shortest to largest, we need to find this last angle. So 51 plus 47 is what, 98? Subtract that from 180, this would be 82. Okay, now list the sides from shortest to longest. So the shortest side is going to be EF. And the reason why, again, is it's opposite the, oops, oh, I did that wrong, actually. It's not EF. Let's try that again. So the smallest angle is actually 47 degrees. My apologies. So the shortest side would actually be DF. Okay, the next largest angle is angle D. So the next side would be EF. And the biggest angle is 82. It has to be opposite the longest side, which would be DE. You guys try these two real quick. Number 2, right, says list the angles of PQR in order from greatest to largest. So look at the biggest side. Angle R is the smallest to largest, sorry. The smallest side is 5.9, so angle Q would come first. It's the shortest. Next is 6.1, so angle P. So angle Q, angle P, and the largest side is 6.8, so angle R would have to be the largest. Right, this next one you're doing the same thing, but this time you're comparing the sides. Start with the smallest angle, 29 degrees, so ST has to be the shortest. 30 degrees comes next, so SR would be next. 121 degrees is the largest, so RT comes last. It's the largest. Okay, the last thing we have here is, this kind of goes back to that problem we did, it says triangle inequality theorem. And what it says is the sum of the lengths of any two sides of the triangle must be greater than the length of the third side. So that's kind of what we're talking about, is if I add, like they have nice color coded here, if I add the red and the green one together, that has to be longer than the blue one. Or if I add the green and the blue one together, it has to be longer than the red one. Or if I add the green one and the red one together, it has to be longer than the green one. This goes back to what we're talking about, that sandbox problem. And it simply says that the two shorter sides together have to be longer than the third side. Otherwise, they wouldn't reach. So here's how we can apply that. This says a triangle has one side length of 14 and another side length of 9. Describe the possible lengths of the third side. So here's how we do this. Either 14 and 9 could be the two shorter sides. If they are, so let's say our third side is X. If 14 and 9 are the two shorter sides, we know X has to be greater than those two added together. 14 plus 9 is 23. So we know X has to be less, oops, I did that wrong. We want it to be less than 23. So if I add my two sides together, I know my third side has to be smaller than those two. But there's also a limit on how short it could be. Let's say X is the shortest side. Okay, that would make 14 the longest side. So what we do is instead of adding these two numbers together, we just subtract them. 14 minus 9 is 5. We know X has to be greater than 5. If X were 5, 5 plus 9 would be 14. They would be equal. Remember we talked about how if you have 14, and then I laid it down this way, I laid 9, and I laid 5. They would meet there if you laid them evenly, but it wouldn't be a triangle. So they have to be longer than 14. So again, pretty easy. All you do when you're doing a problem like this is to find the limit on the longest it could be is you add them together. So 14 plus 9 is 23. It has to be less than that. And then you find the shorter limit, you subtract them, and that's going to give you the lower limit, and it has to be greater than whatever that is. This one's just a little bit different. It says a triangle has one side of length 12 inches, another side of length 20 inches. Describe the possible. Actually, that one's the same as what we just did. You guys pause it for a second. I want you to try these problems really quick, and then we'll come back and talk about it together. So that first one, right? We want to find the possible lengths of the third side. So you add them to find the upper one. So 12 plus 20 is 32. So we know that our third side has to be smaller than 32. And it has to be bigger, greater than, subtract those two. 20 minus 12 is 8. So we know it has to be bigger than 8 and smaller than 32. It could be anywhere in between that. Hey, the second 5, 6, and 7, we haven't gone through examples like this, but we have enough information so that we can. It says, decide whether it's possible to construct a triangle with the given side lengths. All we're going to do is add the two shorter sides together, and they have to add up to be more than the longer side. So if I have 4 and 9, 4 plus 9 is 13. That's bigger than 10. This one's good. Okay, that one could have those side lengths. Again, add the two shorter sides together. 8 plus 9, those add up to be 17. That is not bigger than the third side. So this would be a no. Okay, they cannot form a triangle. Okay, on number 7, you pick the two shorter sides, 5 and 7. You add them together, that comes out to be 12. That's equal to 12. That still doesn't work because if I have 12 and I lay down a piece of 5 and 7, if I lay them flush or flat with that, they would reach and meet, but that wouldn't form a triangle. They have to be bigger than 12, longer than 12. So all you do, really simple, is you add the two shorter sides, and it has to be longer than the third side. Okay, so those are the two main those are the two topics we're covering in this section. The number one is indirect proofs, right? You make an assumption of the opposite of what you're trying to prove, and then you show why that has to be wrong. And by doing that, you prove that the original statement has to be true. And the second thing is just knowing these inequalities in triangle, in a single triangle. You compare the angles, you can compare the sides, you can compare the sides by comparing the angles. And then this last one, just kind of knowing what are the two shorter sides together have to be longer than the third side. Thanks, guys.